All right, this is one of the centers meteorologists use almost on a daily basis, the Storm Prediction Center. It's one of our go-tos. Jacob, you're going to tell us all about it.
Especially as we're getting into summer severe weather season, we're working through the National Centers for Environmental Prediction, this time talking about the Storm Prediction Center. It's located in Norman, Oklahoma, on the campus of the University of Oklahoma, in the National Weather Center building. They have two branches. The operations branch has 3 to 6 convective thunderstorm forecasters there at a time. So convective thunderstorms, you get those storms to bubble up in the summertime. It's a convective process, and that can lead to severe weather. They monitor multiple areas of the country and produce national forecasts. They also have a fire weather forecaster on staff at all times because they're responsible for forecasting the spread of large wildfires. And then the other branch is research, techniques, and development. So the ideal scenario with severe weather is you have the Storm Prediction Center issuing outlooks in the days before a severe weather event. The day of the event, they issue mesoscale discussions, which really hone in on areas of thunderstorm development that could turn severe in the coming hours, and maybe hint on issuing a severe thunderstorm or tornado watch in the next couple of hours. And this can get a little technical with the certain parameters that are in place in the current environment. Then the watch gets issued in collaboration with the Storm Prediction Center and the local National Weather Service offices. Then the National Weather Service offices issue those much smaller warnings for the imminent danger of severe thunderstorms or tornadoes. So at the Storm Prediction Center, they take a lot of data from forecast models and draw these outlooks all across the country. Now in the extended range, days 4 through 8, there's a lot more uncertainty, so they're just trying to target patterns that have the potential for a higher end severe weather outbreak. And then in the days 1, 2, and 3 outlooks, they have a 5-category scale, and one of the forecasters at the Storm Prediction Center will kind of explain how they go through this methodology of forecasting severe weather in the days before a possible outbreak.
So in the extended period, much more reliance on the global model guidance, the ensemble guidance. We've turned to using the AI tools that we have in our toolkit now. Those have proven very helpful in the extended period. As we get closer to the near-term severe risk, there's much more of a dependence on the observational data. That's really key here at the Storm Prediction Center, focusing on the observations to ensure that the model data is really capturing the risk correctly.
So today's risk of those severe thunderstorms is really highlighted in the Oklahoma, Kansas, and northern Texas region, where there's a level 3 out of 5 risk for numerous severe thunderstorms. And this risk is based on large damaging hail, severe winds, and tornadoes. And it's all of these probabilities combined. So the risk of a lot of severe storms is really driven by the probability of being high for damaging winds. The tornado probability is not that high in Kansas and Oklahoma, but hail and especially damaging winds are really driving that enhanced risk of severe thunderstorms. And Harry will explain why all these probabilities can be combined into that one outlook map.
So the categories are actually driven by probabilities for each individual severe weather hazard, that being tornadoes, large hail, 1-inch diameter or greater, and severe winds of 58 miles per hour or greater. And that's probability of occurrence within 25 miles of a point. And then those convert to the categories. Inherently, those categories are coverage-based due to those probabilities, but they all also have to do with the potential intensity of storms as well, with intensity increasing from that level 1 up to that level 5 risk.
So when we're showing those risk categories on a map, going from level 1, isolated severe thunderstorms possible, all the way up to, let's say, level 3, numerous severe storms possible, to the rare level 4 and 5, where widespread severe storms are possible and likely. So it's coverage-based, but also intensity of the severe weather possible. So here's an example from April 27th of this year. They're really good at their jobs because this is the verification of their outlook. And you can see where a lot of reports were of tornadoes and damaging wind and hail right in that bullseye that they predicted of having a severe weather outbreak on that day. And you can really see the evolution of the long-range forecast. leading to the forecast in the immediate days before the severe weather outbreak there. So using the longer range to then hone in on the greatest risk area. That's a loop from 8-day forecast all the way down to the forecast the day of a severe weather outbreak earlier this month. So some new things that they're developing is the timing of the greatest threat of the severe storms. So this graph would show, let's say, between 4 and 9 p.m., your severe threat is the greatest in your location. So that's some new information that they're just developing now, as well as using artificial intelligence tools and developing ways to manage all the data that they have to look at to make the forecast. They also have these new conditional intensity forecasts. So there's uncertainty if a storm will develop. But if a storm does develop, that could be a very strong, destructive storm that could maybe produce a long-track tornado or very damaging hail. So communicating that conditional intensity is something new that they're trying to get on board with. The other branch that they really focus on, or the forecast side of things, is with fire weather. You might not think that these two fit together, but there's a lot of similarities between fire weather forecasting and severe thunderstorm forecasting. They both use ingredients-based approaches. Where do these ingredients come together? Where do they overlap in time and space to either support the enhanced severe thunderstorm risk or that fire weather risk? So with the fire weather, critical fire weather days, they're forecasting the potential for large fire ignition and spread with low relative humidity and strong winds to spread those wildfires rapidly. And they also forecast for dry thunderstorms, meaning that there's not rain coming from the thunderstorm cloud, but lightning can spark a fire. So today's fire weather outlook is in that elevated classification in parts of western Texas and southern New Mexico, but you have the elevated, critical, and then extreme level on their scale. Here's an example from a couple years ago where you had very high fire danger in parts of the southern plains, and that was communicated here on this outlook map that they drew. So it's a lot of forecast model data that they have to look at to draw that easy glance map for either fire weather or for severe thunderstorms. And like you mentioned off the top, we use that every day. We communicate that to you on air, whether it's going to be isolated severe storms possible, numerous severe storms possible, or even that rare widespread severe storm threat.
So true. And we, as meteorologists, we can't do it all, right? And the Weather Service here locally issues the warnings, but it's the watch that comes from Norman, Oklahoma. It's all a collaboration. All of the stuff that goes on behind the scenes, it's amazing just to have an accurate forecast. It really is truly amazing.
Well, I'm glad I got you guys watching.
Yeah.
And
me
that
too.
National Center, the Storm Prediction Center.
It's a great one to tour. I
Yes.
love that tour.